Engineers, my Vice President of the Math and Engineering Club, and he's a full-on NASA boy. Please give a warm welcome to my friend, Jesus Palazuelos.
Good afternoon, everyone. So, this all began with an apple falling on Isaac Newton's head while he was falling asleep under a tree. Isaac Newton questioned this and he said, how did this happen? And then I'm going to explain to you Newton's laws and what they mean and why they matter to our universe. And then so, I'm a Physics 4B student here at Mount SAC. I have completed Physics 2AG, Physics 4A, so yeah, I'm very heavy on physics. And I'm going to explain the first, second, and third law of Isaac Newton, Isaac Newton's first, second, and third law, and why they matter. So first and foremost, we're going to start with Newton's first law. And all Newton's first law says is that force is equal to 0. So I'm going to give an example of this. That chair is not going to move until I act the force upon it. Until I accelerate it, it's not going to move. And so you guys may be thinking, oh hey, this only applies for things that are not moving. That's not the case. This also applies for things that are moving, and I'm going to explain. So imagine that you're driving to San Francisco on the 5 freeway on cruise control. You take your foot off the gas and brake pedal. So you're driving at a constant velocity. And then I'm going to tell you now that if you're neglecting friction, the net force on you is 0. If their speed is not changing, then the total force on your car is 0. And you guys are going to see why in Newton's second law. So now you guys know first law of Isaac Newton. We're going to move on to Newton's second law. The second law states that the change in momentum is over the change in time is equal to the total force on you. So now that we take off cruise control when you're driving to San Francisco, we're going to put our foot on the gas pedal and we're going to accelerate this car. And you can imagine if it's a Ferrari, we're going to accelerate this Ferrari to 80 miles per hour. And when we go from 60 to 80, and now that we accelerated it, there's a force on us. But you guys may be thinking, oh, this is only for anything that's speeding up. No, it's also for slowing down. So we're going to take our foot off the gas pedal, put that thing on the brake, and then we're going to slow down. And now that we slow down, the speed is going to change. And when speed changes, the acceleration is negative, and that means that the total force on the car is going to be negative. So now that I explained Newton's second law, let's move on to Newton's third law. Newton's third law simply states that it's action-reaction. So any force that acts upon, there's always an equal opposing force. So imagine that I punch this wall, for example, and you guys question, why does it hurt me? Why does it hurt when I punch this wall? It hurts you because of Newton's third law. So if I punch this wall as hard as I can, then that wall, the force that I produce, the wall is going to come back at me towards my hand, towards my whole arm. It's going to come back at me with the same amount I just produced on it. That's why it hurts. And then another example is you guys are sitting and why aren't you guys sinking? Why aren't you guys falling entirely? Why is that happening? Well, let me tell you this. Gravity is pulling you down, but the normal force from the ground to your feet is keeping you guys up. And that's why you're going through that. Now let me explain why all these laws matter. First law, why does it matter? If the net force is equal to 0, this building, the total force should be equal to 0. If engineers did not take that into their consideration for their calculations, this whole building would collapse. And that's according to my engineering 40 professor, Javid. And that's true. If this whole building did not equal to 0, this whole thing would collapse. Same with bridges. The San Francisco Golden Gate Bridge, the whole thing would collapse as well if the net force did not equal to 0. Now let me move on to Newton's second law. Why does it matter? Well, we all know about bungee jumping and skydiving and why is it, and it looks really fun, but it's also very dangerous. So without Newton's second law, engineers wouldn't be able to calculate, hey, the maximum weight capacity of these activities, and then it would be considered unsafe to do so. Newton's third law. Why does it matter? So there's beams in these buildings, leaning towards us. If I were to place a beam leaning towards it, if engineers wanted to take it into consideration, then the whole beam would just go through the building completely. And that's why Newton's third law matters. So what I just went over with you guys is that I just went over the first law of Isaac Newton's second law, his third law, and why they matter. And then without these laws, we would be living in a dangerous world. And now that I told you about these laws, now you can see the physics that surrounds us.